Well, hi everyone. All right, well today we're going to talk about ellipses, and I thought for this we'd just get right into it, right down to the nitty-gritty part of it, and just show you how to graph one. Here's a elliptical equation, an equation for an ellipse, and you see x squared and y squared is in the equation. X squared is over 9, y squared is over 4. So I'm going to draw an x and y axis here. Okay, now the x squared is over 9, and the standard form is x squared over a squared plus y squared over b squared equals 1. So this is in standard form. Now the a value here is 3 and the b value here is 2. So over the x, if I go from the center, which in this form the center is the origin, I'll go 1, 2, 3 units here and 3 units this direction, so I'm at -3 here. And then over the y, you have b is 2, so I go 2 units here and 2 units here, and kind of make an ellipse will look like this. And that is all there is to the graph on that. And I think we have a video there that shows previous how ellipses are made, and we'll talk about that in a minute. But this 0, 2 and 0, -2 are, this is a co-vertex and this is a co-vertex. This 0 or 3, 0 and -3, 0, these actually are each a vertex. Okay, and they are more of the major. They're the ones further out from the center. And they're also on, you got right here, the x-axis here on this ellipse is the major axis, and the y-axis here, that is the minor axis. And these are not lines, they are line segments, so they end at each vertex. Okay. And of course you got 0, 0, that's the center. So there's a little bit of the vocabulary. Now when you look at a lot of times we'll talk about the length. So the length of the major axis is, in this case, from -3 to 3 is 6 units long. The length of the minor axis is 4 units long here. And in general, A is the major axis, so it's 2 times A. And the length of the minor axis is 2 times B. Now, there's one more. There are foci, plural for focus. We have 2 foci here. And the equation we use A and B, but we have c squared for an ellipse equals a squared, the major, or the vertex distance, a squared minus b squared. So in our example, c squared is equal to 3 squared minus 2 squared. 9 minus 4 is 5. C is the square root of 5. Now the square root of 5, that's around 2.4 or so. So I'm going to put it right there is a focus. And remember, the focus, each of these foci here are what was needed. This is square root of 5, 0, the exact, and it is a focus. And the focus here is the negative square root of 5, 0. And you've seen videos how they're drawn. The distance from each focus, no matter where you are, is the same. This plus this is equal to, if I pick a point right here, this distance plus this distance. That's how this whole thing was made. So just understand that concept as well. All right, so got a little bit of the vocabulary in. Let's look at some examples. And here's the first example I have. It says, write an equation for an ellipse with vertices at 0, 9, and 0, negative 9, and foci at 0, 7, 0, negative 7. So I want to draw it first. Let's see. If I make this 9, actually I'll make it 10. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, here's my x-axis. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 0, 9, and 0, negative 9. 1, 2. Okay, this is negative 10. 0, negative 9. And then the foci are at 7 and negative 7. So that's what we would use to make the actual ellipse. Now, if you'll recall, c squared is equal to a squared minus b squared. Now, because the foci is always on the major axis, that's another thing we probably could say. Foci are on the major axis. Okay, so this is going to be a more vertical. This is a horizontal ellipse because it's longer horizontally than it is vertically. This is going to be a vertical ellipse because it's longer vertically than horizontal. All right, well, c squared is equal to a squared minus b squared. We do know a is 9. Always go with the big number. We know c is 7. Okay, so this is 49 equals 81 minus b squared. So if I subtract 81, I'm looking at negative 32 equals negative b squared. So 32 is b squared. So when I take the square root, b is going to be the square root of 32. If I wanted the exact value, let's see, 416 times 2 makes 42 or 32. So that would be 4 radical 2 is b. And square root of 30 or square root of 25 is 5. Square root of 36 is 6. So it's somewhere between 5 and 6. 2, 3, 4, 5. I'm going to just put it right here. Say that that is square root of, well, I'll put the simplified version, 4, so that you can read it. I'll make this 4 radical 2, 0. 1, 2, 3, 4, 5. and I'll make this negative 4 radical 2 and 0. All right, and then I'll just come out here. Okay. Try to make it, there's no points or anything, so I'm trying to make it as smooth as I can. Oops. Okay. And I'll kind of erase this part here. All right. So there's my ellipse. That's not what we wanted, though. We wanted the equation, but we have what we need here. B squared is 32, so it's actually x squared over a squared. No, x squared over b squared this time. X squared over b squared. B squared is 32, because this is along the x, plus y squared over 81, when we square a, is equal to 1. That's the equation of this ellipse here. Now, if we have to translate it so it's not centered at 0, 0 anymore, it's centered at hk, your equation, if it's a horizontal, okay, I'm going to change something around here. I want to be consistent with how the book we're going to use. I want to change this to y squared over 81. Put the big first, over x squared over 32, plus x squared over 32 equals 1. That's just a consistency thing. I know they're equivalent, but we'll start with the major axis first, and then the minor axis second. Okay, just for clarification. All right, well, for a horizontal, all we got to do is go x minus h squared over a squared plus y minus k squared over b squared equals 1. That will move it like we want. Okay, now vertically, let me start with I'll go y minus k squared over a squared, because a is bigger. If you look, a is bigger than b, which is bigger than 0, over x minus h squared over b squared equals 1. This one's horizontal, this one's vertical. The foci will be along the horizontal, so we would add or subtract from the center. HK is the center. We would add or subtract the C value for the coordinate for the foci. One's H plus C, okay, and one's H minus C, okay. So this is the foci. Now, on this one, the foci would come off of the y coordinate. And vertices are off of the h coordinate, h plus or minus a, okay. On this one, they're off of the vertical, it's off of the y coordinate. And then co-vertices would be h plus or minus the b value, which is the smallest of all of them. Okay. Not necessarily. It's smaller than a. B and C, we don't know their relationship. And then this would be off of the y coordinate, k plus or minus b. All right, just for some information there. All right, write an equation for the ellipse with vertices at negative 3, 8 and 9, 8, and co-vertices at 3, 12 and 3, 4. I'm going to graph that. I just want to take a look. Negative 3, 8 up, okay? And we got to get up to 12. Okay, I'm going to kind of go over here. Up 12, down to 4. So this is all above the x-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll mark the 10, 11, 12. 1, 2, 3, 4, 5. I'll put negative 5 there. 4, 5, 6, 7, 8, 9, 10 there. And I don't need to worry about the negatives, doesn't look like. So I got vertices at negative 3, 8. 1, 2, 3. I'll count. 1, 2, 3, 4, 5, 6, 7, 8. There's a vertex. 9, 8. 9, 8. And co-vertices at 3, 12. 3, 11, 12. And 3, 4. 2, 3, 1, 2, 3, 4. Okay. I don't know. I just kind of like to look at the... Looks to me, if we draw here and here, that we're looking at a center of 3, 1, let's see, 5, 6, 7, 8. This is like 3, 8. Now is 8, yep, long 8, long 3. Oh, I should have just looked at the y-coordinates of the vertices and the x-coordinates of the co-vertices here. All right, this one is horizontal. And so I'm going to write my equation as x minus 3 squared over 1, 2, 3, 4, 5, 6 over 6 squared plus y minus 8 squared over 1, 2, 3, 4 over 4 squared, and that equals 1. And then we'll go ahead and write 36 and 16 in this problem, and we've got the equation. So we're all good there. The coordinates of the foci. We've got to take c squared equals a squared, which is 36, a squared minus b squared, minus 16. So c squared is equal to 20. C is going to be the square root of 20, which is 2 radical 5. And that's what we've got to add. Square root of 20 is between 4 and 5. 1, 2, 3, 4, and 5. So there's one vertex, which I'm going to write as the y-coordinate is 3 plus 2 radical 5. And I'm keeping these exact, I think you're noticing here. And the y-coordinate is 8. And this is 3 minus 1, 2, 3, 4, right around here. This focus is 3 minus 2 radical 5 and 8. So I'm going to just write it real quick. 3 plus or minus 2 radical 5, 8. Those are the coordinates of the two foci. All right, well, let's just keep going with this. This is the last example, so I'm just going to do this in one video then. Find the coordinates of the center and foci and the lengths of the major and minor axes of the ellipse with the equation x squared plus 4y squared minus 2x plus 24y plus 21 equals 0. Then we'll graph it. A little side note there. So I'm going to rearrange. I'm going to put the x squared plus, we've got to complete this square. So I got the x squared minus 2x plus, well, I'm going to do that in the next step. 4y squared plus 24y. At this point, I think I'm going to subtract 21 from both sides, equals negative 21. Now, I'm going to complete the square with this. I'm going to complete the square here. So I've got x squared minus 2x plus blank. And I'm going to factor the 4 out of these two terms. Y squared plus 6y plus blank equals, now since I'm on the other side of the equation here, I'm going to add what I put here, and I'm going to add, that's plus 4 times what I put here. So I'm adding the same amount to both sides to complete the square. Well, okay, negative 2 over 2 squared. That's negative 1 squared, which is 1. So I'm going to add 1 here and here. And then 6 over 2 squared. That is 3 squared. That is 9. So I'm going to add 9 here and put 9 in there. This is x minus 1 squared plus 4 times y plus 3 squared equals negative 21 plus 1 is negative 20 plus 36 is 16. All right. Now, if you'll notice, any form we have here, we have it set equal to 1. So I'm going to divide both sides by 16, which means I have x minus 1 squared over 16 plus 4 times y plus 3 squared over 16 equals 1. Okay, this is going to work out pretty nicely. You might have been able to do this in fewer steps, but I'm going to write it all out. Now 4, if I divide top and bottom by 4, I've got y plus 3 squared over 4 equals 1. So I've got it simplified. This is this equation rewritten. I've just rewritten the equation so that it's in the ellipse form. We've got to find the coordinates of the center. Well, let's do that. I know that the center is at 1, negative 3. Okay, the foci. All right. C squared equals a squared, which I'll use 16, minus b squared, which is 4. C squared is equal to 12. C is equal to, if I take the square root of 12, that's 2 radical 3. All right, and I can put plus or minus. I haven't been doing that, but those are the C values there. Length of the major axes. The major axis is equal to, okay, 4. This is 4 squared. So 4 times 2. A is 2, or 4, I mean. 2 times 4 is 8. The minor axis is 2 units. Square root of 4 is 2. 2 times 2. The minor axis is 4 units long. Anything else? Okay. Okay, I actually haven't quite done this yet. I don't have the foci on here yet. I do know that it's 2 radical 3 from the center. Now the x is first, so I'm going to be adding and subtracting from, it's a horizontal axis. I'll be adding and subtracting from that x coordinate. So I have 1 plus or minus 2 radical 3. Those are the 2 x coordinates. And the y coordinate is negative 3. Okay, so let's draw this. Last thing we've got to do is graph this. We need to place the center at 1, negative 3. Okay. We need to go 1, it's over 16, so A is 4. So we go 1, 2, 3, 4 units here. 1, 2, 3, 4 units here. 2 units here, 2 units here. So here is our nice pretty ellipse. I missed. Okay, I can do better than this. So I am all right. And then with the foci, 2 radical 3, square root of 12, right? That's between 3 and 4. 1, 2, 3. So we'll put this here. 1, 2, 3, there. Okay. There you go, guys. That's all I have for ellipses. So if you think that's a lot, it is done. It is done on ellipses, and that'll take care of a couple days, I think. All right, take care.